Hello and welcome to another video with me, Elizabeth Bishop, your Autodesk Certified Instructor. In today's video, we'll be exploring the compute options available to us when we mirror or pattern features inside Fusion. Have you ever wondered why, when you're doing a pattern or a mirror and you use the default option of optimized, you get this error pop up, and despite the preview showing us what we want it to do, when we press go, we don't end up with what we want. But in this video, I wanted to explain what each compute type does so you can choose the best option from the start. So let's take a look at a slightly more simple example to work with on this. So when I create a pattern, I'm choosing the features option, and in this case it's quite a simple operation. I just want to pattern this feature, which is the extrude, and I did an extrude with a join. So optimized, our default option, the top one, is the fastest compute option, and this creates identical copies of the features by patterning the feature faces. It's great for speed and performance, and especially on large patterns with multiple instances. So selecting my axes along here, I want to create a pattern of 3 by 3 like this. And that's what I want. I want that pattern to create those 9 columns. And selecting that optimized pattern there, we can see we only end up with these 3 columns here. So optimized is best for simple geometry that connects parts that may be recomputed lots of times in a design, and that's frequently changing, e.g. the timeline recompute is easier each time. But when the part being patterned won't change. It's essentially the same as the faces option, but it's easier to select through the features. However, as you can see, this option doesn't give us the 9 columns that the preview shows. And this is because Fusion is unable to calculate how the faces create a body without the same face of that original box at the base of the column that we didn't select. However, if we switch over to identical for our compute type instead of optimized, identical acts in a similar way to optimized, and it's still fast, but it creates identical copies of the features by replicating the results of the original features. So it's a more reliable way of creating an identical copy of an object. It's fast with optimized, but it's slightly more reliable. And this is great when you're creating geometry that you're patterning that's likely to change. It's more reliable than the faces, so it's less likely to cause that error we just saw with the optimized. And in this instance, we get the 9 columns as shown in the preview. And if I open up the bodies, you can see that each one of these is a separate body. So hiding that cube, we haven't had this join to the cube option here. The only one that's joined is that first one with the body there. And all of the other 8 columns are identical to just that column on its own. So in this instance, it doesn't join to the other box despite the original operation being join, because it computes it as the shape of the object rather than the whole operation. Now, the interesting one to have a look at is if we jump to adjust. So if I change the operation to adjust, we end up with body 1 being the column, but with these 2 columns joined to the body. So computing that option and replicating that join. We've then got the 3 individual columns here, solid columns there, and then the third box here, the 3 columns over here have actually joined to this box. So on their own, they create the joined operation, and it mimics that operation of the first one, creating that join. So the adjust option can create potentially differing copies of the feature by patterning both the features and calculating the extents or terminals of that, which means it's great for adjusting situations, but it does require a lot more computational power. So it's best kept for when it's actually needed, but can be used in those more complex situations. And this becomes a really powerful tool, particularly when mirroring or patterning features that use offsets from surfaces. So let's take a look at an example of that. So I've created this example here. I've got a solid block with a curved surface at the bottom, and I've created this hole, this extruded cut here, using offset from surface. So I've selected this curved surface and I've done a 10mm offset from that surface. I've then added a construction plane, a mid plane between the 2 ends there. Now this time, if I do a mirror, and again, I'm mirroring that feature. So I want to mirror that extruded cut across the mirror plane. Now you'll see with the optimized setting, so our simplest setting, we get what we expect from a mirror there. So it mirrors that across the plane. And the same outcome is achieved with identical. It's a simple enough pattern here, and we can get the same results with optimized and identical there. However, if we choose the adjust option in this case, what we get is that extended hole through the surface which maps to the offset of this curvature on the bottom of the plane. So that's where the adjust option can really come into play, and it's really powerful to adapt to the situation that you've got. So if we head back to that locking screw, we can see that this can be demonstrated not just on rectangular patterns, but it works on all of the pattern and mirror types, including the circular pattern here that we had on the knurled screw, using either the identical or adjust option in this case. So thank you for listening. If you've got any questions, please do post them in the comments section below. If you've liked this video, give it a thumbs up, and I'll see you in the next one.